this 3 steps to sketch for function transformations, we are going to transform the reciprocal function. So we want to graph y equals 2 over x plus 1. And we'll do this using our on the graph method. Here's our equation, and here is our setup. All right, so first we want to know that this equation is transforming our parent graph y equals 1 over x. Y equals 1 over x. And that's our graph we nicknamed butterfly. It's got the curves in the first and third quadrants, and it's got the asymptotes on the axes. Okay, so before we jump in and analyze the transformations, we probably would benefit from rewriting this equation, just because it's a little bit difficult to see what impact that 2 in the numerator of the fraction is having on our graph. So let's rewrite this as y equals, we'll write 2 times 1 over x. Okay, that's the same thing, but it's just made much more clear that that 2 is a vertical transformation. It's a vertical stretch, and thus will affect the y coordinates. Okay, and then of course we still have the plus 1. All right, so by doing that, now we can go to step 1, analyze our transformations, and it's pretty clear that nothing is going on in that denominator with the x, so there are no horizontal transformations. Our x's will stay the same as the parent function. All right, so now let's move on to our vertical transformations. We see there are 2. There's this 2 out front and this plus 1 in the back. And we know we should apply these in PEMDAS order, so multiplication before addition. So our first transformation that affects the y's is that 2. So we'll multiply our y's times 2, or we'll stretch by that factor of 2. All right, and then once we do that, we can apply the shift, the up 1, or adding 1 to our y's. Okay, so now that we know what transformations are happening, we can plot our parent points, and then we'll apply transformations to get our intermediate graphs until we get to the final one. So have some different colors, or do this lightly. We'll start with our parent points, which remember are 1, 1 for that curve in the first quadrant, and -1, -1 in the third quadrant. And we're not going to draw the asymptotes on there, but do notice that they are there. The original parent asymptotes are at x equals 0 and y equals 0. All right, so now let's switch to blue. And we'll apply our first vertical transformation. So this is multiplying each of the y's by 2, or you can think about it more visually as doubling your distance away from the x-axis. Okay, so let's mark that with x's. So that y of -1 becomes a -2, the x stays the same, and the y of 1 becomes a 2, or we've doubled our distance away. All right. So now we've done that, and all we need to do is switch to a different color. Let's move to red. And from the blue graph, we'll apply our final vertical transformation. We'll move up 1 or add 1 to the y's. So blue x up 1, other blue x up 1. Okay, so we have applied our transformations. And now we can go to step 3. Let's darken our points, and we'll sketch in our graph, and we'll also sketch in the asymptotes here. Okay, so darkening our points first, and then a little bit about these asymptotes. So your asymptote, that's your vertical asymptote, your x equals 0, that can only be affected by a horizontal transformation, namely a shift. Okay, we didn't have any horizontal transformations, so that one's pretty easy to see. It just stays put. Okay, but our horizontal asymptote, the one at y equals 0, multiplying the zeros by 2, the y equals 0 specifically, so that value of 0 by 2 doesn't do anything. But that shift is the key. That shift vertically up 1 is going to move that asymptote from y equals 0 to y equals 1. So that vertical shift will impact that horizontal asymptote. Okay, and notice that that asymptote stays halfway between the two major points that we have graphed. Okay, so everything looks good, as it should. We're ready to sketch in our graph. Sketching in. And there you have it. It's y equals 2 over x plus 1 using our on the graph method.